All right, back to this. I don't even know where I left off. I think I said, however, the indicated resistance with an ohm meter is dependent on the voltage of the meter. Yes?
Yes.
All right. A digital VOM, so that's volt ohm meter, will measure voltage drops. So it has a little diode checker function on it. You're supposed to put on the diode checker function on. I say supposed to because the ones I have don't work. Put it on the diode checker and put the leads across, and it should tell you a voltage drop. And then based upon that, it should tell you if it's a good or bad one. According to this, a silicon, S-I-L-I-C-O, a silicon will show about a 0.6 volt drop in forward bias. That's FWD, forward bias. And a 0 volt drop in reverse bias. The germanium ones, G-E-R-M-A-N-I-U, germanium will show about 0.3 forward. I'm probably not really on F, but just go with it. There are different types of diodes. Different types. Well, what's one other type?
Schottky.
Oh, you're way down my list. But you are correct. Oops, now you just screwed me up. There's lead ones. These are ones that are really heavy. Now it's light, emitting diode. And of course they emit a light. Photons are released when electrons meet the holes in the junction. And of course, depending on the material, you get different colors. Depending on the color, on the material. Material, different colors can be produced. And I think I told you about what happens if you have I think a 6 volt battery will do it. And you want to see which way is forward or reverse bias with your diode, so you just put it across the terminals. It makes a, have you done it before? Yeah. It's very loud, isn't it? Yeah. It's a, I know, nobody wants to do it. It's a very loud pop.
We should do it.
And then what are you left holding?
Just the terminals.
Hey. Or in other words, how to strip an LED off the terminals. Put it across the battery, it will explode, and you'll be left with 2 little terminals going, oh, that's it. Huh?
DIY terminals.
You have what? White terminals?
DIY.
DIY terminals. There you go. Thank you. All right. Voltage drop will be different for each color. I have not tried this, but that's what I've been told. Voltage drop will be different for each color. Something I should do one of these days. All right. We have laser diodes. And I should do this. Laser diodes.
I was just thinking.
Now I won't be able to stop. Just like Sophia said the word distributor today. I think she was making fun of me, and now I can't not say it. And I told her, don't say that. I can't not say it. I keep saying it over and over. All right. So similar to an LED, where would I find a laser diodes?
In a laser beam.
What's that from?
Think of that one all on your own.
I can't remember.
Used in optical drives.
Oh, that's right.
Optical drive. Another thing of the past, optical storage drives.
I'll go through all floppy disk.
Like, now I have to explain what a CD player is. The CD player.
Or that Tamagotchi that.
Yes.
Hey, I knew a bunch of friends that had.
Steve, you have any
I
input?
had a Tamagotchi.
You got any input? Oh, okay.
So I suppose, yes, floppy disks. You guys know what a floppy disk is?
Yes.
Yeah.
Steve,
Which
explain
ones?
it.
The small ones
Yeah,
or
or
the
the
big black
large
ones?
ones.
Oh gosh, I think at home I've got some of the big black ones. In my office I have probably a couple hundred.
Yeah, same.
Or I brought them in so I could I had to take them to run them through the Magnaflux and erase them. All right, photodiodes. Who uses what? Oh well, all these conversations. Photodiodes. What's photodiode?
Picture with that.
Takes pictures.
There we go. No, the NP junction is designed to sense light. So when light reaches material, a DC voltage is produced,
Oh, so it is like photosynthesis.
such as solar panels, light sensors, and I don't have this in my notes, but I want to say also like smoke detectors.
You're right. I thought photodiodes were different than solar panels because the diode receives power and it's like a switch.
I thought so too, but this book said no. So maybe a different type. There's probably different types. So, but for our application, I would definitely go with the smoke detectors, even though it's not in there. So, how would I do that? I don't know. Okay, what, Prince, was your thing?
Shock key diode?
Oops, I'm already misspelling it.
Shock key diode?
SCHOTTKY. Shot key diodes. They have a lower voltage drop. They're more efficient. And have faster switching speeds. However, the disadvantage is that the diode has a larger reverse leakage. It's something you can get when you eat those chips that have reduced fat. Sorry if you don't get that. I'm sorry. I'm not going to explain it. The disadvantage is that this diode has a larger reverse leakage. What does that mean?
When it's reverse bias, some power flows.
There you go. Reverse bias, some power will flow. Some current will go through. So, all right. One more. Come on, Prince. One more. You're on the spot.
I don't know.
Way to let us down.
Zener. Zener diode. All right, so a Zener diode allows current to flow in the forward bias just like normal. So allows current to flow in forward bias. Forward bias. Yeah, we can just go with that. Just like any other diode. But also, it also permits current flow in the other and reverse bias. You can write that? Would that make sense? What do we call that? Like a wire. So no. So also permits kind of like that. Current to flow in reverse direction when the voltage reaches a certain value. So you could use it in such a way that if you had like a voltage spike and it went above a certain value, you could then use that type of diode on the other side of ground, so you could send that voltage spike to ground. But you wouldn't have then just your circuit grounded. So just ground if you had a voltage spike. So also it's current flow in reverse direction. Where am I here? When the voltage is above a certain value. When the voltage is above a certain value. Known as the breakdown voltage. All right, so some considerations about diodes. Things you need to know as a mechanic or other stuff. 1, diodes can get hot. And are often attached to heat sinks. What is a heat sink?
Something that quickly takes heat away from something.
It's basically.
Really, I was expecting something better from you. It's like next to the kitchen sink, but so yeah. So a heat sink is something that is going to pull the heat out of the diode. So we'll see this shortly. One of your last projects, we start talking about alternators, and alternators have 6 diodes in them, and they're actually pretty large, but they get hot, and so they are in fact attached to a plate, and that plate is then attached in such a way that it can dissipate out the heat. So a heat sink is a plate or something that allows heat to be dissipated out of the diode, to save the diode. We've seen this already. They are used in rectifiers and a rectifier.
Rectum thing, they killed you.
What is a rectifier? I heard it. Rectifiers allow AC voltage, or just AC voltage to be converted to DC. Well, how does that happen? Hey, remember this?
Nope, go back.
Where did we see this?
About 3 weeks.
I can't remember.
Yeah, what were we talking about when we did this?
Oh, that goes that way, and that goes this way.
Meters. So these are diodes, right?
Right.
All right, so we have the negative, I was going to ask you, which way is forward biased, which way is reverse biased? So if this is negative, is this one forward or reverse biased? Forward, because that'd be positive, and it's showing from positive to negative, flowing that way. And as we had talked about in the meter, you just have to follow the direction. So here we have an AC source, but we always want the flow to be going the same way. So that's why it's called a DC load, because we need the load to be from negative to positive all the time going this way. So it comes up through here, and it's got a choice. This is right now in the negative. So this is the negative side. So can it go this way? No. Of course not. And why not? I mean, obviously because the arrow says why not, but why not? This is one of those things where you have to actually seek to understand. Why can't it go this way?
Positive side.
What's that?
Negative to negative.
Okay, it cannot turn this one on because if the negative is right here, this is showing current flow from positive to negative. Comes up to here and the negative matches the negative, so therefore it's
Good.
good. So it's forward bias. It flows through here. Comes back down to here. Gonna flow?
No.
No. So it's gonna come through here, back around, up. Okay, so now we're this is the weird thing. So okay, so now we're on the positive side, right?
Yes.
So you come through here and you kind of look at it and go, well, wait a minute. This is positive, but it's suddenly turning on this negative. No, what happened? Why shouldn't it go this way? Well, it can't go this way. You'd think it'd go this way and back around. They should have drawn it that way. So it gets to here, you got two negatives. Why is it going this way and not this way? What's that?
I think you said it wrong.
Why is it going this way
Oh.
and not this way? Because if I'm right at this point and all I can see is a negative and a negative, it's got to stop, right?
Because there's higher voltage on the other side.
Okay, so this is where you get into the theory of less positive and more positive. So in comparing B to A, this right here is the full voltage source across here. So I don't want to say it wrong, but looking at it this way, this is the negative side as compared to this side. Can you follow that? So if I come here from B to A, this is full-blown, we could say this is what? I don't know, we'll say it's 12 volts. Between here and here is 12 volts. Between A to B is a full 12 volts. Got it? Because I've crossed the load. Between B and A.
So what will be between B and D?
What would be the difference between B and D? D is coming right off the positive source. So, how am I going to explain this?
You could say that the power coming out of the DC load only has enough energy to get back to the positive terminal.
I like that. Let's say that again. The power source only has enough to get back to here.
Terminal, yeah.
Okay. I don't always love this diagram, but I do need you to understand that, though, when you look at something like this and you see that it's like, well, both of those are negative, and I just said this is positive. You do have a voltage drop across here, correct? So the voltage drop across here means that this is negative in respect to this. Well, let's look at it this way. We're coming through, this is positive. Do I have a voltage drop across here? If I took a voltmeter, that works. I took a voltmeter and I connected across here, do I have some sort of voltage drop across there? Okay, and what lead am I going to hook up here to this spot right here? The negative or the positive lead?
Positive.
Think it through.
Negative.
Everybody see that? If I have a Simpson meter, because I'm only going to read one way, this one has to be, let's try again. Pin. Got my voltmeter. I got a red lead and I got a black lead. Which side's a black lead going to go on? And remember, current is flowing if we use not conventional, but electron theory flow. It's coming up this way, here, here, down this way. It's coming this way and up this way and back down, right? Follow the arrows. So they're showing the arrow in electron or conventional? Electron, okay. So here I've got my meter. Black lead. I want to put black lead on B or D.
D.
That did not work for me. Bravo or Delta?
Bravo.
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 Bravo. Black lead's got to go there.
And the red could.
And so therefore the red is delta. All right, because here's the positive, and so this right here is the positive lead right there. Can you see that? So it's right there. Now I know some of you, I watched you. How are you going to hook it up? This way, then that way, then this way, then that way.
Just gotta justify your answer.
I know, 3 times. All right, so if the negative lead goes here, now can you see how this is more negative than that? There's a small voltage drop right across this. So if we had to measure it out, we could say between Bravo and alpha, you're going to get a full 12 volts. Between E to F, you would get 11.4. And then across B to D, you get 0.6. So there's another voltage drop. So that makes this negative in respect to D. Follow? All right. That's the best I can do. So if you don't follow, then I don't know what to tell you. So
Which one's the higher potential, I guess?
D.
So that one would have
The positive.
6, and then on the B side it'll be have like 0 or something?
No. Remember, voltage is the difference in potential between 2 places.
Mm-hmm.
So B to D would be 0.6, but E to F would be 11.4. So this is positive in respect to that, but this is negative in respect to that. And then you just reverse it around. And that's why it works that way. That's why. So this one, we reversed it. The AC is swung the other way. So it's going to come up. It's going to get to delta right here. This is a negative. So which one is it going to turn on? Is it going to flow this way or that way? And that one's easy because you got 2 opposites. So you can figure it out. So you're going to go to C or is it going to go to Bravo? C. All right. So up to C,
Charlie?
gets to C. Charlie, is it going to come down this way?
No.
No. So it's not. It's going to flow this way.
Down to Echo, the Foxtrot.
Bravo.
Up here. Same reason why. So why does it get here and why does it go both ways? Because if you put a Simpson meter across it or voltmeter, you're going to find that this is the negative side, that's the positive side. You do get a voltage drop, so it's going to come back around. Oh, we got to talk about those yet. All right. So considerations. One of them. Stay away from them. All right, so considerations. What do we got? Rectifiers allow voltage to be converted to DC. Oh, that does bring me to transistors. All right, here we go. I'm going to put it together. It's not so bad. Let me get out my scribbles. Now, you guys want to hear a funny joke?
Always.
All right, Tim, tell one. No? Don't have one. All right.
It's funny you said that.
All right, well, he's sitting right there. Transistors. All right, we have 2 types. 2 types. What is one type? Come on, you've heard it. NPN. And that looks like that with an arrow that is going that way. Because 1 and not pointed in. Is that what NPN stands for? Nope, but it tells you which way the arrow goes. Arrow's not pointed in. The base is what type? Is the base N or P? Base is P type. So that makes this the base. And 3, we have a collector and emitter are N type. We have the other type, which is PNP. Well, I didn't write it, but point did. In. P. Just point it in. Okay. So the base is N-type. And then the collector and emitter are P-type. Well, what can it be used for? Transistors can be used as a switch or solenoid. And you saw also amplifiers, but I'm not going to get into the amplification part, just a switch or solenoid. All right. Connections. This is where I'll try to make it not confusing. All right, so transistors must be properly connected to work. Must be properly connected to work. The emitter to base junction must be forward bias. Okay, that makes it on. This is going to freak you out. In an NPN, the base is positive. And the emitter is negative. In a PNP, the emitter is positive to the base. Right? And that's pretty simple. So that's one. So 1 point. The emitter to base junction must be forward biased. Second point to make it work in the connection is base to collector. Base to collector junction is positive to the base. Oops, I didn't mean to write that. Base to collector junction is reverse bias, is what I meant to write. My bad. Base to collector junction is, because I was thinking, well, that just doesn't work out. So just highlight that in black. Base to collector junction is reverse bias. All right, so we had emitter to base junction must be forward bias, and base to collector junction is reverse bias. And then in an NPN, the collector is, this is where that term comes in, more positive than base. And in a PNP, collector is negative in respect to base. All right, that's a good place for you to go, what just happened? What happened? How am I going to remember this? What the heck's going on? What is all this going on? Let me see. And I had all of, and I can keep going on. I had some other notes here. Consider the two resistor diagram, and then don't think as voltage in absolute. And have these resistors, and I kind of go through this: what's more positive, what's more negative. But I'm hoping that where we just went with the Simpson meter on those diodes, going, look, see how it's positive, but yet there's still a voltage drop to be had. So this is more positive than that is, or negative. You can kind of see that you get in this small stuff. And then when you look at a diode, and even schematically, which works, and you start labeling it out, and you have collectors. Oops, that didn't work out well. Collectors, emitters, bases, and you got, well, the base. So we'll make this, this is not pointed in, it's pointed out. So what type is this?
NPM.
You can't tell because that's just such an awful. And you're like, I don't know, what is that? It's just you're not supposed to put a star on it, I don't think. Okay, so is that a NPN? Why is it NPN? Not pointed in. All right, so I'm saying, so we've got, make my drawing over here. Actually, I'm going to change it just a little bit so it matches this drawing I have in front of me, so I can be sure that I'm actually either wrong with the drawing or not. So we'll go this way. So this is the emitter. This is the what? Base. And this is the collector. All right. So we can look at some rules. Emitter to base junction must be forward bias. So emitter to base has to be forward bias. In an NPN, the base is positive and the emitter is negative. All right, so we can go through all of that. It's like, whoa, what just happened? But then I came up with this idea of redrawing this. And I drew it in this way. NPN. All right, NPN, right? Okay, got some wires coming out. This is the base, because this comes down like that. And it's important that the base goes to the middle. And the middle on an NPN this goes NPN. See how I do that? All right, now let's stop and think. What's going to turn this on?
Power from the base.
Oops, keeping true with my drawing here. So I made it this way, negative, positive. We'll just do one, and I brought it up here, and is it on?
No.
Why is it not on? And he's right, it's not on.
Base is the out.
Because you remember the little cartoon with the guy with the balls and stuff? Some students tried to find me one of those lantern things. They're going to make me wear it. Yeah. Okay. So do you remember that? Remember that drawing, or I said that little cartoon? And so they had. I don't know if I can do it offhand. The way they had it drawn, kind of, in a somewhat of weird fashion like this, where this was the end sections. This was the P section. Oh, sorry, that was an N section. And nothing really seemed to work because it had this P built up right here. Oh, that's funny, I had a bunch of P built up. So had P right here. And it did not work until there was some sort of voltage placed upon here. And that voltage had to be what? Positive. Okay, so when that was positive, it turned this on and then everything was flowing, right?
Yes.
Okay, so, but until this positive was right there, did anything happen? Okay, so now come over here to look at this drawing. I've got the same thing on. Do I have anything going to my base, my P? So is it on? It's not on at all. All right. But the way this would be connected, now I wouldn't want to just pick up a wire and just connect it to there. Most of the time, the way these things are drawn is something similar to this. And this is going to tap into there. So variable resistor, if you will. So this is the positive side, is it not? That's the negative side, correct? Yes. So do I have, and we're just going to look at it right here. We're just going to examine this right here. Is that on?
Yeah.
Is this positive? Is that negative?
Sure. Yeah.
That works, doesn't it? All right. And so now, is current going to flow from here that way? Yes, it is. It is. Because, if we go back up here, what turned it on? In an NPN, the base, I'm sorry, go back up a little more. There. Don't do that. Emitter to base junction must be forward bias. And do I have the emitter to base? I have the collector in this one, but I should have went the other way. But do I have this forward bias? All right. So I'm going to leave it right there. Let's sink that in. And we'll come back to this tomorrow. So I can see you guys are like dying on me.